Curvilinear coordinate systems 22. Classically, the angular momentum L is given by r cross p, where r is the position vector of an object and p is its linear momentum. In quantum mechanics, the value of the angular momentum is obtained by letting a vector differential operator L-op acting on a wave function psi. Angular momentum is L-op acting on psi. The angular momentum operator can be obtained using the correspondence principle of quantum mechanics. This principle says that the operators are obtained by replacing classical objects in the classical equations with operators. Therefore, L operator is R operator crossed with P operator. The position operator is just a position vector. R operator is R. The momentum operator is minus IH bar gradient, where I is the square root of -1 and h bar is Planck's constant divided by 2 pi. Show that in Cartesian geometry, L operator is given by this expression, minus IH bar EX hat, parentheses y del del z minus z del del y, minus IH bar EY hat, parentheses z del del x minus x del del z, minus IH bar EZ hat, parentheses x del del y minus y del del x. Okay, so first of all, let's start with the position operator in Cartesian coordinates. R operator is simply equal to the position vector R, which is x EX hat plus y EY hat plus z EZ hat. The momentum operator is minus IH bar gradient del operator, and if I write this in Cartesian coordinate system, this would be minus IH bar del del x EX hat plus del del y EY hat plus partial derivative with respect to z EZ hat. And L operator we're going to obtain by doing a cross product between R operator and P operator, the linear momentum operator. Okay, so L operator is the cross product between these two, so we're going to have minus IH bar EX hat, and for the position we have x, y, and z, so EX hat, EY hat, y, and EZ hat, z. Now the order matters here, so this is R cross P, not vice versa, so we have to write x, y, z first, and then we're going to write the components of the linear momentum operator. So minus IH bar del del x, minus IH bar del del y, and minus IH bar del del z. And we have to take this determinant to find our angular momentum operator. And we're going to expand it with respect to the first row. So for the EX hat part, we're going to have y del del z minus z del del y. So we're going to have L operator is equal to minus IH bar crossing out the first row and first column, y del del z, y del del z minus z del del y. And this is the x component, so this is in ex hat direction. For the next term, we cross the first row and second column, x del del z minus z del del x, but we have a minus sign here, so we're going to start with z del del x. So minus ih bar z del del x minus x del del z, and this will be in ey hat direction. So I've already operated the minus sign. So this normally this would be x del del z, but because of the minus sign, it's minus x del del z. It would be minus z del del x. Now because of minus signs, plus z del del x. And the last term is crossing out the first row and third column, x del del y minus y del del x. So we're going to have minus ih bar x del del y minus y del del x. This is an easy hat direction, and that comes with a plus. So this is our final answer basically for the angular momentum operator. If we compare it to the suggested answer, minus ih bar y del del z minus z del del y ex hat minus ih bar z del del x minus x del del z ey hat minus ih bar x del del y minus y del del x ez hat. So it's identical to the suggested answer. Alright, so we have used the correspondence principle to obtain the angular momentum operator from the position operator and linear momentum operator. Position operator in Cartesian coordinates is ex hat plus ey hat plus z ez hat. And linear momentum operator is minus ih bar gradient written in Cartesian coordinates, del del x ex hat plus del del y ey hat plus del del z ez hat. Now when we take the cross product of two vectors, first we have to write the unit vectors in the coordinate system ex hat, ey hat, ez hat. In curvilinear coordinates we would have scale factors here. So x, y, z, and these components del del x, del del y, del del z with minus ih bar up front. So we take this determinant with respect to the first row, and that gives us exactly the answer we're looking for.